All right, in this video, I'm going to talk about this concept of acceleration. It can be a tricky concept for some people, but we're going to try to clarify that with some examples. So the definition of acceleration is how fast you change your velocity, not how fast you change your speed. So which means direction has to play a role. In other words, if you change your acceleration, if you change your direction, sorry, you must be accelerating even if you're going at a constant speed. And I'll do some examples with that. So acceleration is it's a vector quantity also, is the change in velocity over time. Okay? Now, in your car, there are three ways you can accelerate / decelerate. You can put you have your gas pedal, that's going to make you go from low to high speeds. You have your brakes, which will make you go from high to low. And you also have the steering wheel, which will change your direction. And by changing direction, your velocity is changing. It could be like, you might be making a turn at 20 miles per hour, but the fact that you change in direction means you are accelerating. And when we do forces, this will make more sense, okay? So let me just do some quick examples here. I'm gonna keep this video short. So let's say you have a car going from 30 miles per hour to 40 miles per hour. And let's say it does that in 1 second. Or, yeah, okay, that's fine. And then we have a truck, okay? That's going from 70 miles per hour, and it's gonna go to 75 miles per hour, and it's gonna do that in 1 second. Now, what I don't want you to confuse here is the acceleration has nothing to do with how fast you're going. It has to do with how fast you're changing, okay? So in this case here, the car changes by 10 miles per hour every second. The truck, on the other hand, changes 5 miles per hour every second. So we can say that the car, even though it's going at low speeds, has a bigger acceleration because it was able to change its speed faster or quicker, okay? So that's pretty much the example. Now, if I draw a velocity versus time graph, okay? And if I do, let's say it looks like that, okay? If I do the change in velocity, if I do, in other words, the rise, and over the change in time, which is the run, okay? So the change this way is delta V, okay? The change this way is delta T. So if I do this ratio of delta V over delta T, or we can just call it T, that's the slope of this line here, of this segment. But that's also the definition of acceleration. So I can say that acceleration, okay, is the slope in a VT graph. That's important. That's going to come in handy when we do a graphical approach to acceleration, velocity, and displacement. Okay, and that's it with this video. Thank you.